Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a precision problem in which you have a measurement of some sort and you have different measurements, and you have to figure out what the average is, what the precision of that measurement is, adequacy and accuracy. So let's get into this. But before we do, please make sure you like this video, subscribe to my channel, hit that notification bell so you can get notified of other videos that I put out, and comment in the comment section. Let me know what you think, and if you have any questions. So let's get into this. So you have a bathroom scale. This is like a scale at home that you would use, and you step on and off of it several times, and you get different readings. So, for example, your first reading is 164 pounds. Your second reading is 166. Third is 164. Then you another 162, and then 164. So when you take the average of this, you add these numbers all together and you divide by the total number of the trials or the times that you stepped on the scale. So in this case, you would add these numbers up and then divide by 5. And when you do that, you get an average of 164 pounds. Okay, so that's easy enough. You got 164 pounds for an average. And so the next thing you want to look at is the precision. So the precision of this is done in such that you're going to use the average and you're going to subtract your average from the highest and lowest values. And so the rule is that when you subtract your average from the highest and then you subtract your average from the lowest value, you're going to take the largest difference. That means the largest or the least precise measurement. So, so if we look at 164, let's find our highest. This is our highest here. So that's if we subtract 164 from there, we get a difference of 2, right? So there's a difference of 2 there. Okay, so that's going to be a difference of 2 for the highest value. And if we look at the lowest value, again, if we're going to subtract the lowest value from the average, and again, that's going to be a difference of 2. And since they're the same, then the precision here is plus or minus 2. So you could see that if this is the average, then 62 is minus 2 and 66 is plus 6. So it's a plus or minus 2. So they're plus or minus 2. Now, if this was instead a 61, right? If this was 61, then the difference between here and here would be 3, right? So we have a difference of 3. So because that would be the larger distance, we would take this over the 2, and then this would be plus or minus 3. Okay. So next is adequacy. So we're defining adequacy. Let's say we're defining adequacy as less than, if we have a difference or a precision here that is, let's say, less than 5%. Less than 5%. Okay. So then all we need to do is take our precision here. This is plus or minus 2. So 2 divided by the average multiplied by 100 is going to give us definitely something less than 5%. So you would just take the 2, divide that by 164, multiply that by 100, and you calculate that. It's definitely going to be less than 5%. If this was 100, then it would be 2%, but this is more than 100, so it's even going to be less than that. So whatever that number comes out to be. So let's go ahead and calculate just for completion, because I know people out there like, calculate it. Okay. So 2 divided by 164 times 100 equals, all right, 1.2%. So it's like a 1.2%. So that's well within the range. So that would be adequate. Now, what about accuracy? We need to compare it to something. So here we have in the doctor's office a scale that is more precise, more accurate, better than the one we have in our bathroom scale, supposedly. And we step on that scale wearing all the same clothes that we did before. So everything's the same. And we weigh 185 pounds. And they want to know what's the accuracy of our scale compared to this scale. And so the way to do that is the formula where you have the actual. Sometimes it's the actual minus the measured, or it's the measured minus the actual. How that happens, it doesn't really matter because you're going to take the absolute value of it. And so it ends up being the same number. So I've seen it as the measured value minus the actual value. So this is the absolute value of that. So the measured value would be our bathroom scale. That would be the average. The actual would be the doctor's office, because we're assuming that that's a lot better than our scale. I mean, the doctor's office has to have pretty good equipment in it. And then you're going to divide that by the actual value, which again is your doctor's scale, and you multiply that by 100. And so you do that. Let's see here. So we're going to take the measured value, which is our average, so 164. We're going to subtract from that 185. 185 equals, we get a negative 21, but we're going to take the absolute value of that. So that's going to be 21. We're going to divide that by the actual value, which is 185. And then we're going to multiply by 100. And we get 11.3 or 11.4%. So 11.4% error. That's a pretty high error. So as far as our bathroom scale goes, that would be pretty low accuracy. So remember, accuracy is how close you get to the actual value. So the closer your measured value is to the actual value, the smaller that distance, then the less error there is, and the more accurate your instrument is to the actual value. Okay, so I hope this was helpful. Let me know if you like this video, if you learned something from this video, if this was helpful. Please, again, smash that like button, subscribe to my channel, and hit that notification bell so that way you can be notified of other videos I'm putting out. And put a comment in the comment section. Let me know what you think, and if you have any questions that I can answer. Thank you very much for joining me, and have a great day.